Yeah. No AI in this one, guys. Buckle in.
We're almost all engineers on this team, so.
Yeah.
Oh no.
All right. Welcome to Platematic, where the struggles of designing base plates is no more. So I'm Norman No. I'm from Core Studio. My team members are Dave, Yushi, Alexandra, Abhishek, Amit, Shri, and Rob. We had a lot of people working on this during a virtual hackathon. We also had a lot of different backgrounds and a lot of different time zones. So this was definitely interesting in a virtual hackathon. And what is base plate designs and why is it a problem? So basically a base plate is that plate that connects the column to a foundation. So essentially we have hundreds of different softwares that allows us to design the column and the foundation. There's only a handful that are able to design the physical plate. And of those different platforms, none of them transfer information between different softwares. So it's usually a manual process of taking, my base reactions and my forces using Excel or some other, SQL or something, and transferring it over to these other platforms and then sending the information to some construction documents, usually in Revit. So the thought process was we can kind of compile all of these efforts into one application and automate it. So we can have one desktop application that pulls information from the structural analysis software and then sends the information to Revit so it can be streamlined. This was our kind of original scheme of what the desktop application would look like. It'd be pretty simple. We would import loads from different structural analysis software, so SAP, ETABS, RAM structural systems, have some very basic design parameters, whether it be the base plate width, height, thickness, different foundation types. And then you'd be able to see some sort of user interface that shows, here's what your base plate design looks like, here's what the design results are on the right side so that you can validate your design. And then, most importantly, being able to print out some sort of report and save these files locally so that you can use them in Revit. So once you're able to save the files locally, the thought was we could take this information, have some sort of Revit user interface that pulls those local files and then populates a schedule in Revit or changes parameters on columns within Revit. We weren't really sure how it was going to work, but this was the general idea. All right, so to kind of visualize the workflow, we have SAP, ETABS, and RAM as our starting point. We, for the virtual hackathon, we tried to split up different priorities, and we had quite a few people on the team, and we all kind of wanted to work on stuff that we were uncomfortable with because that's how you learn the most. So we had Alexandra working on learning the APIs of different structural analysis softwares. Rob casually made this massive SAP 2000 model for us to use for testing purposes, and I was helping out on that front as well. Dave and Amit worked on the WPF application and kind of prettied it up with some cool WPF libraries. Shri worked on the physical designer, and Rob helped out on that as well. And for the Revit application, Abhishek and Yushi took over that front. All right, so yeah, we had this rhino-looking SAP 2000 model that I think
goes to headquarters.
Yeah. Okay. And yeah, I think he used Asterisk or something like that to produce this model. And we needed a starting point to pull base reactions from and also to get column geometries from. So the thought is you can select one of these columns in this massive model, and it would pull the analysis results from the bottom of the column and shoot that information over to our desktop application, as well as the column geometry. So, and then once you have the base reactions and the forces and all that good stuff, we can use some sort of designer that Shri worked on and, use the simple AEC design guide equations to spit out, does this base plate design work? What's the minimum thickness? What's the maximum bearing capacity? And then, send the results back to the user interface. So this is what it looks like in person. You see I selected a column on the left-hand side, so both windows are open at the same time. This is Amit and Dave's user interface that you're modifying the base plate geometry and the foundation geometry, and then running it in real time so that you can get some design results. And then once we had that information and we were able to save that those designs locally, the thought was we could have a button in Revit called Platematic or whatever it may be, and it would populate a schedule within Revit with all of those local files. So that's what you're seeing here. Press the button and goes to the schedule, and you have a base plate type, the column that's assigned to that type, the width, height, and thickness. So very simple. And future work, there are a lot of people working on a lot of different things here, and we kind of went through a large variety of different softwares. So, this was definitely a first pass at things. So we need to clean a few things up, make it a little bit more presentable, a little bit more clean. And, we just touched the surface of base plates. If base plates get you excited as I do, then there's a lot more to learn and to implement into this tool. You got anchor bolts, embed plates, shear lugs, brace frame connections. The list goes on and on and on. So definitely excited to keep working at it. And then also optimization. So for mass building designs like the building that Rob showed, possibly pulling in all the columns for the structure and doing it all at once is something that we'd definitely be interested in pursuing. And then the best ways to save results and document them in Revit. There's a lot of different approaches. So kind of cleaning that out and getting some different opinions is important. And then lastly, if this goes, way into the future, why stop at base plates? You can take this so many more directions when it comes to connection designs or different small details that are a pain in the butt for engineers. So that is future work, and it is open sourced. I'll post this in the chat. So these are our collaborators, and please feel free to stop by and give us your opinion. Love to hear it. And that is it.
Who came up with that name?
A third-party contributor. No, I'm just kidding. It was you, Shannon.
Actually, it was Jonathan. I won't take credit.
Okay.
You're welcome.
Yeah, so we do need some marketing help, that's for sure. I'm just kidding. All right, that's it. Questions?
Yeah, cool. I mean, it seems very well thought of and considered, and seems like addressing a massive pain point for you guys. I mean, I'm not an engineer, and so I wouldn't know. But maybe a question from mostly from ignorance. What do you think is prevented such tools from happening before, like? Or what necessity? I mean, what's the novelty in the hack?
I think a lot of people, a lot of different companies have these platforms within their softwares, and they don't want to jump into, outside. So like, for example, SAP and ETABS doesn't want to connect with Revit. Bentley doesn't want to connect with Revit. So really the hack is kind of pulling all these different softwares together and creating one platform for it. What's stopping people from doing it? To be honest, I don't know. It's been a pain for me for the last 2 years. I've done too many base plates for this to still be a problem. So I think it's really just pulling all the different softwares together and parsing the data correctly.
Yeah, and I think I would just add that the current workflow, the data is completely disconnected from the BIM model for the delivery.
Yeah.
Cool.
And it's like that with pretty much everything that is designed, whether it be connections, even beams and columns. Like there's no analysis data living in your BIM model. So
yeah, I mean, I don't know the details. I mean, how things work on commercial buildings and so on. But like at the ETH, when we when Block Research Group was doing this shell design, like they one of the common things that they established early on was like a kind of JSON type format where every contributing party would either add or read off of the attributes somehow. Like it was CableNet design, but nothing to do with like existing I sections and so on. But still, maybe there is some similarity there. For an industry-wide data exchange, or similar to IFC, but like for structural quantities or entities.
yeah, I definitely think that's the future. That's what we're trying to get to. I think the structural engineering world is a little bit lagging behind a few other industries, in my opinion. But
yeah, I say the other thing is that typically LOD 300 models, we don't model base plate. There isn't even a Revit, a BIM element for it. It has to be a custom component. So, but eventually, if we have the workflow, then we can apply the associated data to that component and populate it.